It's a pleasure being here again. Good morning. Today I'm going to talk about Kamailio and a new database backend, Redis. But actually, when we started to benchmark the results of this implementation, we found quite some gems, like in our overall appliance, which I also wanted to share with you. So overall, it's about supercharging Kamailio, like optimizing SIP and RTP performance of your systems. Actually, the goal was quite, let's say, naive and simple in the beginning. I mean, I'm simplifying a bit, but in the end, what we used before was using a Kamailio instance, or actually multiple ones, and a MySQL backend for that, in particular for all kind of stuff like location information, accounting, dialog information, everything that needed to be persisted basically to the disk to survive a restart of Kamailio. And what we wanted to do is kind of like finding the holy grail, saying, okay, we want to horizontally scale in an unlimited way, one way or the other, and it's going to take a little bit of coding in between, right? In reality, where we ended up with is on the right side. So not unlimited horizontal scaling yet, but surprisingly effective performance improvements and results. But the path to it was really surprising because, as I said, we found quite a lot of things I wanted to share with that. And then afterwards, I'm going to talk about, okay, how can you leverage these kind of things? So when we started off with the implementation somewhere in the beginning of January, it was quite easy, let's put it that way, or we were quite quick to get the first results in, right? So there was a new DB Redis module there. We said, okay, we are finished, now let's see where we end up with our performance tests. And then it took us another 3 months or so, quite unrelated to Redis and the DB module in order to really get stable results. And therefore, I really want to tell a story backwards. So first thing is, along with our new Redis database driver in Kamailio, we were also implementing or putting in place systemd finally, right? So we thought that, first of all, we needed it kind of because it's like the default init system for Debian. We are basing our appliance on Debian, and you get pretty good control over all the applications when you have dependencies and what to start when. So actually, all in all, it's quite great if you can tame it, right? The other thing is we ran into some issues, kind of nice problems to have when Kamailio and Redis start to outperform your overall system default settings, which resulted in quite some interesting benchmark results. And then I'm going to go into the core of the whole thing, like, okay, how can you actually configure a system in order to get there and in order to leverage the new modules. So when we started to do our benchmarking, the results were awesome, right? So it was like somewhere between 100 and 200% faster than when using MySQL end-to-end. Which doesn't mean like the performance of the DB Redis module is 100 to 200% faster. It's more like we're still using tons of MySQL queries and everything. We do the accounting, and for a couple of those things, we now leverage Redis rather than MySQL. We drove down the disk I/O significantly compared to before, and overall, like when you were looking at the high-level view, as I said, it was awesome, right? There were great results. But when you started to look into the details of how the whole performance went over time, we found some interesting, quite peaky patterns, right? And it was all in multiples of 5 seconds, peaking around, I don't know, around 30 seconds all the time, starting to, you know, to show lots of retransmits. And if you just put the system to its limits, you started to see like message drops and so on. And we were wondering what's going on there, because actually the overall performance of the system looked quite okay, right? There was not a lot of disk I/O, not a lot of CPU utilization. It was just like, okay, is it CP doing something wrong, or is it something on the system? And the thing is, it all came down, or lots of those things came down to actually disk I/O in a rather, in a way we didn't predict, right? Because when introducing systemd, you also get journal-D. Right? It's nice, right? You can get like persistent boot logs and all these kind of things. You get this binary logging in there. You can actually query very easily with journal-CTL for stuff like severities. You don't have to grab log files. It's fast. But the problem is, there are multiple problems with that. One problem is that when you drive your system and push it to its limits, it's not unreasonable to have like, I don't know, 2,000 registrations per second, each of them like logging, let's say, 10 lines of log lines. And there are some default settings in journal-D which start to rate limit those kind of things. So actually, it's not logging the whole picture, right? The other thing is that we still use rsyslog to log to the disk. So now we have two elements. One logging like incomplete messages, the other one logging to the disk. And the third thing which caused this kind of unpredictability is that journal-D is actually using memory map file access. So it was kind of like Sherlock Holmes style digging into the system, but Debian has certain default virtual memory settings, which I at least didn't know. One of them was actually mentioned by Henning in the last talk. So you have VM settings. One of them is dirty expire centisex, right? Which means that if there is something in the virtual memory and it's older than 30 seconds, it gets flushed out to the disk, right? And the other thing is that you have a dirty write-back centisex of 500 by default, which means there's a kernel thread every 5 seconds looking for expired messages, and then it flushes it out. And this actually comes then down to these kind of patterns, right? Because every 30 seconds, you flush out like all your log files to the disk, which slows down the overall system so much that you start to see the increases of retransmits on the zip level. So what works for us quite well is tuning that a bit. So to have a dirty expire centisex set to 2 seconds. So we flush out like old messages every 2 seconds. Could be probably less for the cost of like a higher CPU utilization. And we also check for dirty writebacks every 100 centisecs, which is like a second, right? And all in all, what we also did, we completely disabled journal-D persistence. We lose some things like persistent boot logs and stuff like that. But all in all, due to these rate limits that journal-D comes by default, and also having rsyslog there in any case, at least for now, it doesn't make any sense to log them twice, right? So this is why we got rid of that. And actually, it started to flatten our whole overall performance quite a lot, and the whole overall system performance got much smoother. All right, and then there was another problem when testing it, which is that Kamailio plus Redis plus RTP engine is fast. And don't get fooled, it's really fast, especially when you run it on a brand new Xeon Gold 16-core CPU, which we started to do our testing with. The problem was at that point that we started to utilize the system with CP tests, registrations, cores, and in parallel also doing RTP traffic using Star Trinity in our case as a zip tester in order to see the overall system performance, right? The problem with that is that it's not unreasonable to do like 5,000 concurrent cores on a system like that, right? But 5,000 concurrent cores, RTP-wise alone, adds up to around 500,000 UDP packets per second, right? And the problem is, and the zip, I'm not counting in the zip packets of that because that's like small. It's like another 1,000 or 2,000 or something like that. And this is not what your average server network pattern looks like in reality, right? A web server has a totally different pattern. So you're dealing with a lot of small UDP packets. And the default settings of the kernel, or at least our system and the driver, the network driver, is really not suited to that. So the next thing we started to do is investigating how actually it comes down to that we weren't able to utilize the CPU more than 60%, right? And what we found is that the default driver for our network cards we were using only uses 4 receive queues by default, right? So there are 4 kernel threads starting to read packets from the hardware. And that utilizes like your CPU quite well, but you actually kind of like starve out other processes, right? And you can't read fast enough from the system, and you start, or from the network, and you start seeing packet drops there, which results in bad RTP traffic mainly, like in bad media quality. So the first step we did there is actually starting to change that and max out like the number of receive queues on the card, setting it to 8. And the second important part was, and that might really depend on your actually setup, is looking into the queue hashing algorithm that the Linux kernel is actually using. Why? Because what we had is, we had a Kamailio instance there, right? It has one IP. And then we had a SIP tester instance there, which is another IP. And by default, at least again on our network card, but I think it's the default for all of the drivers, is that the default queuing algorithm uses a hash of the source IP and the destination IP, right? And if you imagine, I mean, that would be the case for our testbed, but it's very, what happens there essentially is that you only are going to utilize one single queue in the system due to the hashing. All of the packets flow in the same bucket, right? And the other kernel threads don't receive any more packets there. And you might think about, well, okay, maybe it's a problem in our network setup, right? But if you think about scenarios where you have an SPC in front of your Kamailio, right, starting to also bridge your media traffic, you have exactly the same pattern. Or if you have like 2 or 3 media gateways on the other side, with 2 or 3 IP addresses, you are going to overutilize a couple of receive or a couple of queues in general and not utilize the other ones. So some of them will be overloaded, some of them will starve. It's not a problem if you have all like customers with all different IPs, but if they all appear to come from the same IP address, you're going to run into an issue. And the solution to that, and it's a really quick thing to do, is to change your hashing algorithm to also take into account the source and destination port, right? And then suddenly you're going to see a kind of even distribution across all of your queues, and the overall RTP call quality is going to improve a lot by that. Because you're not going to have any packet drops, any delays anymore, because you can feed in a lot more data or a lot more packets per second into your machine. And there's an excellent Cloudflare blog post there, which describes these kind of things. And if you didn't, you should really read that. So now actually to the meat of the talk, which is Redis related. So that was more like a detour into, okay, what happened when we started to benchmark the whole thing. So the question or the task we were kind of facing is we were adding more and more features to our appliances, and the whole thing got slower and slower, right? So what we really want to do is, okay, we wanted to actually start optimizing for performance again, just in order to increase the density of the whole system, that you don't have like tons of servers. We always had the issue that we were very I/O bound, right, which is a problem in VM setups, that it costs a lot. If you need, I don't know, an AWS EC2 instance with, I don't know, 10,000 provisioned IOPS, right, it's going to be very expensive. So we were thinking about, okay, how can we actually solve that? The tasks at hand were, we needed a horizontally scalable and persistent data store, like surviving startups and or restarts and failovers, in order to write raw accounting records, and in order to handle our kind of volatile data, like SIP registrations, dialog information, presence information. So that is more or less the gut of it. And there was a couple of requirements. I know there exist a lot of solutions out there, you know, like Cassandra and all these kind of things which claim to be doing that. The main problem with that is, and the most important part there was, we needed a solution that is well known and understood within Sipwise, because there is no sense in rolling out a technical solution at dozens of operators, and if something goes wrong, nobody knows how to fix it, right? That's probably the worst case if you have, I don't know, millions of accounting records suddenly being corrupted and you're really losing real money. The other part was, that is kind of shardable on a protocol level. So we didn't want to really change, you know, every single Kamailio module in order to start load balancing the whole thing. So we actually wanted to put in like one box, kind of like that was able on the protocol level to start distributing the whole thing. It should be simple from an high availability point of view, like master-slave replication was totally fine with us. And one other thing is survivability without quorum. So we are getting more and more requests to say, okay, we need geo redundancy and geo-site survivability. You know, there are customers like in the UK or somewhere on some island, somewhere saying, okay, they are part of like a cluster, but if all the internet connections to the, let's say, mainland die, it should still be able to do calls, right? So for us, it actually came down to Redis looking at all the points and starting to evaluate and create them. So the next task was actually, okay, going into the task of implementing something like that. So just a very quick primer to Redis, what it actually is. Basically a key value store on steroids. So it's, you have a key and you can put data structures behind that, like hashes, sets, just a normal key value, those kind of things. It also has like extended things like PubSub support and those kind of things. We were using those technologies already with RDP engine to share states, right? So we knew kind of like how it works. We also were using it to store counter values. And therefore, it was a natural choice using that. The other thing is like a simple wire protocol, just kind of ASCII-based, very easy to parse. It has replication support. And it has several methods of doing persistency, right? Now the problem when you start to look into leveraging a key value store as a generic database backend for Kamailio is you have this key in the key value store, right? And the key must be unique. So as an example, when we look at the user log module, you can't use, for instance, a user domain as a unique key in order to store your fields like username, domain, contact path, flags, expires, whatever, because you could very well have two different clients with the same address of record storing parallel registrations. So what we thought was, okay, then let's use the RUID then in Kamailio, which is generated by Kamailio itself. It's a unique ID. And we could actually leverage that as a unique key. Now, the problem is that nobody knows the RUID, right? The user log module in itself, if you're not using caching, is actually selecting by the address of record. So it tells the database backend, give me all the rows of, for the registrations for this particular user at this particular domain, right? And the only way in order to fetch that is to do a full table scan of the Redis backend, and that is going to be slow, right? So what we started to introduce then is, okay, we have actually two different kind of keys, or actually more, but there are two different types. So one type is an entry key for actual rows. So you need to have a key with like a hash, and there you have all the key values in there, like, you know, user, domain, contact, path, expires, flags, and whatever. And then you need to kind of simulate a schema for modules to generically start selecting them. And what we did is we introduced kind of map keys there in order to do this. So the problem is with DB Redis, as of today at least, it's not plug and play. So if you're going to switch off your DB MySQL and going to put in DB Redis there, you need to do some manual configuration as of now. And most importantly, you need to define those kind of keys. So how does a key look like? For instance, again, if we are looking into user log module, a key definition for a particular table consists of a table name. In our case, like for user log, it's location. For accounting, it's ACK, or whatever you want to name them. And it consists of an entry key, like it's the key type, entry, separated by a column. And we are using the RUID field to form a unique key. So that means that every time the user log module tells the DB Redis module to insert a particular registration into the database, it's going to create a key called, for instance, location, entry, so that would be the type. And then you have this my RUID1 or whatever the value is, right? And the most important thing is it needs to be unique. Otherwise, you're going to override an entry there. And then as a value, you have this hash table saying, okay, there you have all your keys. And therefore, you can use, you know, for the same address of record, like test user 1 and example work, you can have 2 different rows in your database. And then you need to know the patterns that Kamailio uses in order to query the data. And this is a bit tricky. So what we introduced is this map key. So in our case, we know that the user log module is asking the backend, give me all the records for this particular user and domain, right? So what we did is we added another key saying this is the location user DOM. The name is arbitrary. You can name it whatever you want. And the value would be test user 1 and example work, so the user and domain of that. And it's actually a set in Redis. And the content is just the set with the entries pointing to the actual rows, right? So basically, it's just a mapping from a particular query pattern to the actual rows. And for instance, with user log, you have a different query pattern there. So there's a NUT timer, for instance, and an expiration timer, checking the database for expired contacts, which uses the partition and the keep alive columns in order to figure out which of the rows are actually expired. So that is kind of like a worst case scenario, right? Because user log is pretty complex. If you look at ACK, for instance, if you look at the module documentation in the docs, there are some examples there, I think 3 of them. So the accounting, for instance, it's more easy because you're only writing. There is no reading, so you don't need to have, by default at least, you don't need to have any map keys there. You just tell it, this is the entry key, for instance, the call ID plus the time in high-res resolution, which forms a unique key. And you can just put it there. And then however you want to read that from a third-party application depends on whether you need to have another map key or not. But for location, that's essential. Now, the problem is, how would I know the keys? And I don't know either, right? So at the current state, there are 3 different tables which we use at Sipwise, which is location, which is dialog and dialog vars for the dialog module. And I think we're using accounting. And I know how those keys are defined by looking at the source code of the module and looking of these modules and looking at how the patterns look like. So the main task here, the main open to do is for the application developers to collaborate with me in order to create kind of like out-of-the-box key definition for all these kind of tables, because that's like basically the hard work still to be done. It's not that bad if you get the keys wrong, because it will still work, kind of, right? Because if you're doing a select and DB Redis figures that there is no map key, right? You give it a couple of columns, and it tries to form a key out of these columns and try to find it. And if you have more columns you're selecting with, then it starts to compare the key values of the result. And if it doesn't find a map key at all, it starts to do a full table scan and starting to compare like all the values manually, and it's going to be slow. The problem is if you get the entry key wrong, you get data loss, right? So we had that ourselves last week, where we figured, oh, we have a bug because we forgot to define another column of this row, and it started to overwrite rows. So as I said, the main goal in order for the next release of Kamailio, in order to have it in the stable release, is to ship Kamailio with predefined keys. And that is basically the major effort for us now to actually define them, getting in touch with all the module maintainers to figure out what are actually your query patterns. And it's pretty interesting also for these maintainers to think about, okay, how do we actually use the database, because there might be things to be optimized. I think we had a discussion very briefly yesterday with Dialog, which uses some hash IDs, so there is room for improvement. So having said that, where Redis really shines as a DB backend is when all of the data fits into RAM, and when it can serve all of that from RAM. The main problem there, though, is you really want to have some persistence, depending on the data you're storing, right? If it's really just registrations, and you say, well, I really want to be fast, and I keep for instance, my expiration time for my client so low that I have like re-registrations every 60 seconds, you probably don't care, right? Because if your data for whatever reason gets corrupted, your Kamailio crashes, your machine crashes, you get it back up. Within 60 seconds, the client will start inserting that again. It's always a kind of like a trade-off of, okay, what can I afford in terms of data loss versus how much does it cost me to have like 100% reliable data, which doesn't exist in any case, right? So what exists there in terms of options is you have an append to file method in Redis. So every statement basically you put into Redis is going to be written to a file, right? And then this file, kind of like a journal, is going to be reread once you start up. And it takes a while. So the second option is to have RDP snapshots. And basically, common practice is that both of them go together one way or the other, right? So you say, I want to write into my journal file, if you want, all the statements. But at certain thresholds, I really want to compress it, want to have a snapshot on the disk in order to load faster. And basically the same with this append to file exists in InnoDB, where you have to define how often you want to fsync, like how often you want to sync your data to the disk in order to be safe in terms of a crash, right? So I think that the standard way of doing it is doing it like once per second, which means that in the worst case, you could essentially lose a second of data, which could be a second of accounting records. So if you do 1,000 cores per second, you could lose start records or stop records for 1,000 cores. Then again, what does it cost you in terms of not being able to build this 1,000 cores versus running the whole infrastructure in the long run? And again, the important part is, if in doubt, then just run multiple Redis instances for different purposes. Because Redis is pretty lightweight, right? And it's pretty easy. You don't need to have a schema. At some point in Sipwise, we used to even run 3 different MySQL instances per machine for different purposes, right? And that was kind of a nightmare to maintain. But if you do the same with Redis, it's pretty easy, right? You just have like a config file, a daemon, and that's it. You don't have to care about table spaces and stuff like that. And again, if you are interested in the details of that, Redis provides a pretty great topic on that for you to read on and decide which kind of methodology you want to use for your persistency. All right, so we have a couple of to-dos. Again, I want to reiterate that the most important one from a usability point of view to really make it a plugin replacement is ship the key definitions in a file, right? So I already auto-create like all the schema, like which kind of columns exist in Redis from these XML files we have. But what's really missing is, this schema definition, like how do particular modules actually use, in terms of query patterns, the database. There are some nice-to-have things, in particular leveraging Redis key expiry mechanism, because currently one of the main load is also to actually typically I think every 30 seconds go over the whole data set and see and check which kind of keys have been expired and drop them, like which registration have expired. An easy one would be Sentinel support in order to do Redis clustering. And there are a couple of others, like for instance, when you really start distributing the whole thing to leverage PubSub in Redis. Because what you could do is you could have multiple Kamailio instances using write-back as a database mechanism. So you keep all the data in the cache. You just write it back in terms of, or for the case of Kamailio crashing, restarting, whatever, so you can read them back. And what you essentially could do is subscribing to the key space of Redis of your locations, and every time another machine is actually inserting something, you, as a Kamailio instance, will immediately get notified and can insert the data into cache. Kind of similar like how DMQ, for instance, is using that. So that would be something to be added. All right, that's it. Any questions?
Okay, thank you. And question before the coffee break? Anyone around here? Tori? Okay.
Just a question with regards to the network optimizations. We found issues too with high volumes of RTP packets. And one thing that we found was that one core would end up having one CPU and the system would just die from a massive amount of IRQ handling. What we did was, not changing the number of queues, but we dealt with IRQ coalescing. Did you have any experience with hierarchy coalescing, or do you find just adding more queues and changing the hash algorithm resolves the issue of the number of interrupts?
Yeah. Actually, what we did is changing quite a lot of those settings. Those were basically the most important ones, or the most obvious ones, and the ones that brought the most. First, we're using IQ balance in order to start balancing the IQs between all the cores. We didn't, but we did it already quite some time ago, right? I mean, RTP engine was used quite a lot already and was fine, right? What we hit there is more like we were wondering that we couldn't utilize the full CPU, right? And there it came down to, okay, having this high-performance CPU with RTP engine in kernel mode, where we hit the limit of not being able to read from the driver fast enough. So, and that helped it for us. Among like increasing the queue size, because we still have kind of like some peaks on an I/O level. So it's still a bit bursty from a performance point of view. So increasing queue size helps in order to not drop the packets in the meanwhile, because actually it can catch up quite a lot. So that were basically the knobs to start tuning.
Okay, so probably we are ready for the break. We started a bit late due to some infrastructure issues. Catch Andreas will be around, and other guys from Sipwise, like 5 more. So they have a lot of interesting solutions for RTP engine and Kamailio and so. So a rather shorter break because we have the coffee now and some other drinks outside, and then we'll continue with the next session and probably we'll get in our normal schedule. Otherwise, we'll be late for the lunch and we don't want to happen, right? Thank you, Andreas.